Have you ever wondered where the universe came from? How did it all begin? These are questions that have long captivated the minds of humans. The origin of the universe, a topic teeming with mystery and complexity, has been a subject of debate and research among scientists and philosophers for centuries. From the ancient Greeks speculating about the cosmos to the modern astrophysicists working on cutting-edge theories, the quest to understand the inception of our universe has been a relentless pursuit. This pursuit has led to various theories, each one more intriguing than the last, each one trying to decipher the enigma that is our universe. We find ourselves in a vast cosmic playground, filled with galaxies, stars, and planets. But where did it all come from? How did it all start? What if I told you that this infinite expanse of space and time, this universe that we call home, may have emerged from nothingness? Sounds perplexing, doesn't it? The concept of the universe emerging from nothingness is a mind-boggling one. Yet, it's an idea that sits at the heart of our understanding of the cosmos. How do we make sense of this? Let's break it down. Imagine an empty stage. There's no set, no actors, no audience, just a void. This is our nothingness. But even in this emptiness, there's a hidden energy, a potential for existence. This is akin to the vacuum energy in quantum mechanics. In quantum mechanics, there's a rule known as Heisenberg's uncertainty principle. It tells us that we can't know both the position and the velocity of a particle with absolute certainty. The more we know about one, the less we know about the other. This uncertainty also applies to energy and time. The energy of a system can fluctuate for short periods, allowing particles and antiparticles to spontaneously form and then annihilate each other. These pairs of particles and antiparticles, known as virtual particles, are not just theoretical constructs. They have been observed in the lab. They pop in and out of existence, borrowing energy from the vacuum and then returning it, all in a time so short that they don't violate the conservation of energy. Now let's bring this back to the universe. Prior to the universe as we know it, there could have been a state of nothingness, a quantum vacuum filled with this fluctuating energy. A tiny fluctuation could have given rise to a pair of particles. If these particles were kept apart, they could have avoided annihilation, and instead, used the borrowed energy to create more particles. This process, driven by the strange laws of quantum mechanics, could have set off a chain reaction. The energy borrowed from nothingness could have fueled the creation of an entire universe. So, in essence, the universe could have originated from an infinitesimally small point of nothingness. It's a concept that challenges our intuition, but it's a testament to the power of quantum mechanics and the fascinating possibilities it presents. This brings us to the Big Bang Theory, the leading explanation about how the universe began. The Big Bang Theory paints a dramatic picture, a universe born from an inconceivably dense, hot point, a singularity, exploding into existence around 13.7 billion years ago. It's a theory that turns the concept of nothingness on its head. But how did scientists arrive at this theory, and what does it really tell us about our cosmic origins? Well, the Big Bang Theory is a culmination of observations and mathematical models. It's not about an explosion in space, but rather an explosion of space. It's an expansion, a stretching of the universe from that initial hot, dense state. Now imagine the universe as a loaf of raisin bread dough. As the dough rises, it expands and the raisins move farther apart from each other. In the same way, the Big Bang Theory suggests that space itself is expanding, carrying galaxies with it. We're not at the center of this expansion, but rather, every point in the universe is moving away from every other point. And what about the beginning, the very instant of the Big Bang? Well, that remains a bit of a mystery. The laws of physics as we know them break down when we try to rewind the clock to that first moment. It's a singularity, a point of infinite density and extreme heat. Our current understanding can't quite describe what that's like, but here's the fascinating part. The Big Bang Theory doesn't necessarily argue that something came from nothing. Instead, it suggests that the universe as we know it, all the space, time, matter, and energy, was once compacted into an extraordinarily dense state, a singularity. And then, for reasons we're still trying to understand, that singularity began to expand. The Big Bang Theory suggests that our universe actually began from a singularity, a point where matter is infinitely dense, as at the center of a black hole. Fast forward to today, and the universe is a vast expanse of galaxies, stars, and planets. Our universe, a seemingly infinite canvas of celestial bodies and phenomena, continues to expand at an accelerating rate. This expansion is one of the many mysteries that baffle scientists and astronomers, a testament to the enigma that is our universe. The cosmos that we know today is vastly different from what it was billions of years ago. From what was once a singularity, a point of infinite density, it has inflated to a cosmic spectacle of about 93 billion light-years in diameter. But even with this vastness, we are only able to observe a tiny fraction of it, thanks to the limitations of our technology and the speed of light. Speaking of light, let's take a moment to appreciate the stars, those glowing orbs of plasma that light up the night sky. They are the universe's storytellers, their light carrying tales of cosmic events from millions, if not billions of years ago. The light we see from distant stars embarked on its journey long before the first humans ever walked the earth. Isn't that something to marvel at? And then there are the galaxies, colossal structures hosting billions of stars, planets, and other celestial bodies. Our own Milky Way is but one of the estimated 2 trillion galaxies in the observable universe. Each of these galaxies is a universe unto itself, with its own set of rules and idiosyncrasies. Yet despite our progress in understanding the universe, there's still much that remains a mystery. Questions about dark matter, dark energy, and the ultimate fate of the universe continue to puzzle scientists. The very nature of the universe, its origins, and its destiny remain shrouded in mystery. While we may have some theories and understandings about the universe's origin, it's clear that there's still much we don't know. But isn't that the beauty of it? The universe is a grand, intricate puzzle waiting to be solved, a cosmic playground for the curious minds, and who knows, maybe someday we'll unravel its secrets and truly understand our place in this magnificent expanse of existence. The concept of the universe emerging from nothingness is truly fascinating, isn't it? We've journeyed through the cosmic origins, contemplating the paradoxical notion of existence springing forth from non-existence. We've delved into the Big Bang Theory, the explosion of singularity that sparked the creation of all matter, time, and space. We've also peered into the universe as we know it today, a grand cosmic show that continues to unfold billions of years after its mysterious inception. In the vast expanse of the cosmos, we find a reflection of our own quest for understanding, our own search for beginnings and ends. But remember, this is just the tip of the iceberg. There's so much more to explore, to question, to discover. If you found this video interesting, don't forget to like, comment, and share it. Your engagement helps us continue to explore these thought-provoking topics. Until next time, keep pondering the mysteries of the universe.